Hi, and welcome back to Solid Print with me, Ben. And today we're joined by a very special guest, Seiko.
Oh, thank you, Ben. I'm Seiko. I'm a channel sales engineer here at Formlabs, and I'm really excited to be here with Ben to talk about the Fuse1 30W.
Excellent. So we're going to be chatting a bit today about the new machine. I think there's a couple of new materials as well that we can talk about. And just some old classics as well. Bit of history and a bit of everything to do with the Fuse1. What's your favourite machine?
The Fuse1 30W.
Why is that?
Because it's so damn cool.
Excellent. Well, we're going to find out why later today.
So let's start off with who is Formlabs. We create reliable, accessible 3D printing systems for professionals. We've been in the market for around 10 years at this point. We've predominantly been in the SLA, liquid-based 3D printers, and now we're venturing into SLS, which is a powder bed fusion type process. What we do is we make our 3D printers really easy to use and accessible, and I think that's really represented in the ecosystem. Later on, we'll be showing you the workflow, so we're really excited about that. So in today's video, we'll be focusing predominantly on the Fuse1 30W. But before we do that, let's take a step back to talk about SLS printing in general. SLS stands for Selected Laser Sintering, which is an acronym that's being used in the industry, but don't worry if you don't understand. People do call it powder bed fusion as well. I think powder bed fusion is a much better term because it really explains how it works. Essentially, there is a bed of powder where there's a roller that flattens it out. The entirety of the build chamber, which is where all the powder is heated up close to, but below the melting temperature, and there's a laser that shoots down at the powder. Essentially, wherever the laser hits, it trips it above the melting temperature and sinters those powder together, and therefore you get a 3D printed part, and that's how SLS 3D printing works. There are a couple of advantages to SLS 3D printing, so let's cover that a little bit to give you an idea of why people use SLS. This is not necessarily for Formlabs, but just SLS in general. So SLS are using thermoplastics, so these are existing plastics in the world. Some of you who may be using liquid type 3D printers may be familiar with materials that are called, let's say, rigid or tough, which are not materials that you may be familiar with or are working with. But with SLS, these are thermoplastics in the industry that's been used for, let's say, injection molding as well, which makes it a lot more easier. You're essentially using the same material you've already developed a workflow for. For example, at Formlabs, we currently offer Nylon 12 and Nylon 11, and Nylon 12 GF and Nylon 11 CF, which we'll cover a little bit more about materials later on. So that's one of the biggest advantages. The second advantage is in regards to the design freedom. Design freedom is a very common keyword that you hear with 3D printing. And compared to, let's say, traditional manufacturing methods like CNC or milling, you do see a huge improvement. To give you an example, FDM and SLA type 3D printers, which are the fuse deposition modeling and the favorite liquid vat polymerization type 3D printers, you require what's called support structures when you're 3D printing. And essentially, you do want to take that into consideration when you're designing it. So we do have a little bit of design for additive manufacturing, even though it is a huge improvement in design freedom. But SLS takes design freedom to the next level because you don't have to have support structures. Essentially, they can be printed without support structures. So when I was talking about a bed of powder, essentially these 3D printed parts are going to be submerged or buried in powder, and the unsintered or the unused powder essentially supports the 3D printed part itself. So there's no need for support structures, adding in an added design freedom compared to other 3D printing technologies. To give you an example, SLS essentially allows you to print living hinges and assemblies all printed in one shot rather than having to print them separately and then combined together. So that's one of the next huge benefits. The other is in productivity and throughput. So if you're printing, again, with other 3D printing manufacturing methods, you may be familiar with something called a build area, where you have a platform where you can put as many 3D printed parts as possible, and that's how you actually maximize 3D printing. But you're unable to maximize on the Z-axis. And that's where SLS really plays a huge role, especially if you are in production. Because it is submerged in powder, you can fill up the entirety of the Z-axis to essentially fully use the build volume. And that's why SLS is predominantly used in production as well. The next advantage is in regards to material cost. This is in reference to or relative to other 3D printing technologies. One advantage, like I mentioned before, the lack of support structures essentially makes sure that you don't have to throw away material that you 3D printed. And on top of that, the unsintered or unconnected powder can be recycled. Essentially, it can be reclaimed for its next print and reused, and therefore you can really cut down on material cost. So that's the benefits of SLS and how or why more SLS 3D printing is used in the market. Now that we've covered SLS, let's talk about Fuse series product line. We have the Fuse1 30W, which is great for use with high utilization and those who need a quick, rapid prototyping. And on top of that, the Fuse1 is the most accessible SLS 3D printer. So let's spend some time to talk about the features of the Fuse1 30W. The Fuse1 30W compared to the Fuse1 has a stronger laser. As the name may suggest, the Fuse1 30W has a 30W laser and the Fuse1 has a 10W laser. By having a 30W laser, it has allowed us to expand our material portfolio into industrial grade materials and on top of that, print at a faster speed. The other new feature of the Fuse1 Plus is the nitrogen supply. You can run your printers at an inert gas environment. This is an optional feature that you can choose to use. It does have some advantages. For example, when the printers are running, the printers are raised to temperatures which are pretty high, above 150 degrees Celsius, depending on the material and maybe even higher. When these materials are exposed to such high temperatures, the materials will degrade, especially when there's oxygen available. And therefore, by using an inert gas environment, you can actually save the material from being degraded too much. By using nitrogen generators and nitrogen supply, you can essentially use the printers with a lower refresh rate. To give you an example, Nylon 11 running on air has a refresh rate of 50%, where if you have a nitrogen supply, the Nylon 11 refresh rate will go down to 30%. A lower refresh rate essentially allows you to save money and also reduce waste. So let's talk about inert gas atmosphere. There are two ways you can do it, one with a gas tank and the other with a nitrogen generator. If you're using a gas tank, I think it's a great way to start off. If you're trying out this new material and you want to see if nitrogen is helping in any way, you can use a gas tank. However, if you're printing a large print, the gas tanks are not going to last. Essentially, you do have to swap it out, so it's not going to be a long-term solution. If you're planning on running a printer with nitrogen in the long run, it's better to use a nitrogen generator. We do have some specs you can find out on our website for that. I do want to highlight once again some of the benefits with using nitrogen generator. I've already mentioned some of the refresh rates that are improved, but on top of that, some of the materials have seen an improvement in mechanical properties. To give you an example, Nylon 11 with nitrogen has seen an improved ductility, so if you're looking for materials with high ductility, you may want to consider nitrogen generators as well. So let's have a look at print times with some examples. Here we have a comparison between the Fuse1 and the Fuse1 30W. If we were to print these three saddles, the packing density is 9%. With the Fuse1, you can print it in 18 hours, 22 minutes. The Fuse1 30W, you can print it in 14 hours. The print time improves by 24%, and this is thanks to the improvement in speed in the Fuse1 30W. You can see this improvement much more when you are packing at a higher density, especially because the 30W allows for a higher scanning speed. So let's look at another example here of IEC connectors. They're packed at a packing density of 49%. The speed improvement, or the print time improvement, is 39%. Let's look at another example. I think it's more relevant for those looking into production, especially maximizing the Z-axis. These are shaft coupling printed at a packing density of 58%. You can see the time improvement is 50.2%. So you can see how the Fuse1 30W may be a better fit if you are looking into production. I do want to highlight one thing. Here it's mentioned zero waste printing. Essentially, if you are packing at a density equal to or above of the refresh rate, you're essentially creating zero to no waste, and therefore we write zero waste printing. So always aim to pack as efficiently as possible. So that's the Fuse1 30W. Let's talk about materials. First one is Nylon 12. Nylon 12 is a material that does it all. It's not just Formlabs. Nylon 12 is the most predominant used material in SLS. It's a material that balances strength and detail. It's easy to use, and that's one of the reasons why it's predominantly used in the SLS market. It's a high performance material, great for prototyping and of course functional prototyping, and we do have a lot of use cases where they're used for final end products as well. Nylon 12 balances, as I mentioned, strength and stiffness. So if you're looking for something that is a little bit more ductile or impact resistant, then you might want to look into Nylon 11. Nylon 11 is a high performance, high impact, robust, ductile material, predominantly currently used in the market for orthopedics or anything that's wearable, especially because if you're wearing it, it does go through a little bit of impact. On the other hand, if you're using Nylon 12 and you're not looking for ductility, rather you're looking for more of a stiff part, which is the case for parts that need high accuracy, parts you're using in jigs and fixtures, then you might want to look into the Nylon 12 GF. GF stands for glass filled, and you guessed it, it has glass in it. With the glass, it is improved or actually higher tensile modulus, so essentially stiffer and therefore used in high accuracy applications. On top of that, with the glass inside, it makes it more chemically resistant, so there are customers using it for parts that are exposed to solvents in factories. And of course, we have our newest addition in our material library, which is the Nylon 11 CF, CF standing for carbon filled. As the name suggests, it is filled with carbon fiber. It is actually a dry mixture of Nylon 11 powder and carbon fiber. The reason why I'm telling you this is because a lot of 3D printers do use carbon fiber. However, the form in which the carbon fiber comes in may differ based on 3D printer. Ours is in particles. Essentially, when you are printing with Nylon 11 carbon fiber, the powder is laid down as you do in any SLS, and the roller is placed to essentially flatten out the layer. When that happens, the carbon fiber particles are aligned to the direction of the roller, which does result in difference in mechanical properties based on which way you orient your part. So for those using FDM, you may be familiar with anisotropic properties, where mechanical properties differ based on direction. Similarly, with our carbon fiber, X, Y, and Z directions, mechanical properties do differ, so you might want to take that into consideration if you're orienting your parts to print in Nylon 11 carbon fiber. On top of that, as I mentioned before, carbon fiber particles are mixed with Nylon 11, so the sieve used in the post-processing station does need to be changed to a sieve 300. If that doesn't make any sense, don't worry, you can always reach out to Solid Print for more questions.
Right, let's have a look at some case studies then. So the first case study we're going to have a look at is a company that we sell to not too far from our home studio in Coventry, called Vital Auto. These guys produce additive manufacture parts for use within the automotive industry, and these parts can be end use applications. They can be used for internal and also external bodyworks, and they use these machines to actually get initial napkin sketch to a finalized part. With the Fuse1, these guys have actually got 5 of them all in a row. It's very impressive to go and see. And they use all 5 of them to churn parts out constantly, and they really get the best use from batch production with these machines. With the introduction of the Fuse1, they're able to produce structural and mechanical parts to suit for their application and actually create physical appliances there. These parts would have previously had to have been CNC'd, and this can take a week, 2 weeks to do. Whereas with the Fuse1, this is done within maybe a day and a half, and they have their parts ready for use straight away. But that doesn't mean that Vital Auto replace their normal methods of manufacture. Quite the opposite. They actually combine them, and they use a variety of technologies and combine the additive and subtractive together. And even not just that, but combining additives together as well. So they don't just have the Fuse1, they've also got a Form 3 and 3L. And this is brilliant because we can actually see where all of these applications can hold hands and really work together to make a fantastic product. The team mainly use the Fuse1 for mechanical parts such as door hinges and handles, internal uses, but these can be straight off the printer, and there's basically no post-processing that's needed for them. Now, another company which we'll have a quick look at, and I'm sure you guys have watched the video previously on this, but we'll play it again for you, is a company called Heligai, and these guys specialise in drone products. Very excited to show you this clip, as it does show the capabilities of the Fuse1 very well as well.
My name is Ross Embleton. I am the lead product designer here at Heligai. My job is to scope the market, design new stuff that really fills our customers' needs. Heligai primarily supplies and supports drones here in the UK and wider markets, and it's a one-stop shop for anything that could be possibly required drone-wise. This could be a guy running a roofing business who wants to get a drone up and have a look at someone's roof so we can quote them for the repair, all the way through to huge corporations who are using enterprise level aircraft to be able to get huge data sets. Or they're using maybe someone like the BBC who is wanting to do filming, or someone like a science research facility who are wanting to take measurements of certain, in the air, or take water samples from places they couldn't get to. There's the range of our customers is very wide. The two Formlabs printers that we have in-house are the Fuse1 and the Form 3L. The Fuse1 is an SLS type machine which uses a powder, primarily nylon type powder. It uses a laser to sinter it layer by layer, depositing one layer of powder, sintering, depositing another. We found that the parts that we can get out of this are very strong, very reliable. It really is our workhorse printer that it's printing 5, maybe 6 times a week, primarily overnight to save time, but it's a fantastic high quality build printer. The Form 3L is an SLA type machine which uses resin and a laser to produce the parts. The laser will scan over the resin and cure only certain sections of it and pull the part out of the resin. It's very futuristic, it's quite fun to watch. My favourite material that's available is the Rigid 10K. That material you can use to create jigs and fixtures and stuff. Very impact resistant, very hard wearing. But there is a wide variety of materials of different hardness, all the way down to incredibly soft, flexible, rubberized type materials. If you're wanting to produce a component and you're not particularly sure what material would be the best, the 3L is a fantastic machine to use because you can just print the same component in lots of different types of materials and then verify that later on. When we first looked at buying 3D printers, one of the questions that we had was who do we align ourselves with? We're quite fond of following a particular brand and staying within that ecosystem. Formlabs have such a wide range of fantastic technology. It was very difficult to ignore them. We did send parts out to SolidPrint to get some test prints done. Our designs, originally we were doing it on FDM type printers, but we had them done in both the Form 3L and the Fuse1. As soon as we got the parts back, we knew immediately that Formlabs was going to be our choice. And the support that we got from SolidPrint as well was fantastic, so we couldn't ignore that. Using 3D printing technology has enabled us here at Heligai to have the freedom to design parts in ways that we couldn't do it any other way. Working in the drone industry, one of the main problems that we encounter is lightweighting. Being able to do that traditionally would mean a lot of milling, complex 5-axis stuff, whereas with 3D printing, we can just make the part in one go. Time is also a massive thing for us. Being able to run something overnight and not have to wait weeks to come get parts back has been a huge advantage for us. So the parts that we've designed and manufactured here have been easily some of the most complicated parts that I've made ever. Designing for additive manufacturing gives you a freedom that you don't normally have. A good example of this is our cages for the Mavic 3. They're fantastic parts, really strong. They can survive impact at up to 3 meters a second. 3D printing allows you to create shapes that are incredibly complex that you wouldn't be able to manufacture in any other way. Our parts that we've designed for our dog cam units, for example, take a more biological approach to it. Lots of smooth curves and lines, and even the internals that you just wouldn't be able to make any other way than using it in additive manufacturing methods. Heligai has outsourced the vast majority of its manufacturing. Now we've brought these parts in-house, we're able to turn those around much faster. One of the main problems that we have with producing out of house is we don't have oversight. We're not able to sit there and see the parts coming out before they come into our building. So producing them in-house has allowed us to increase the overall quality of our parts, as well as, most importantly in the drone industry, the lightweightness of these parts as well. Now we've got this amazing ability to spec a part, and we know immediately what material it can be made out of. how long that's going to take to produce, how many we can make, and we can design right from the get-go around the material, around the purpose of the part, our ability to make the part. Do we need to orientate it in a certain way in the printer and design the part in a way where, while it's in that orientation, it's going to print well? The whole workflow is really give us this incredible insight into part manufacture. Right from the get-go, SolidPrint have been absolutely instrumental in us acquiring these printers. The guys in the sales team are really responsive to questions, more than willing to send you any sample parts you might want, very quick to get back to you on shipping requirements. The quoting system's great. They do next day delivery on a lot of materials. They're absolutely fantastic to work with.
So that was the Fuse1 Plus 30 watts. Thank you very much for joining us, Seiko. That was really informative. Yeah. So I think there are going to be a couple of questions, both about the new machine and also some new materials. So how can I actually, get my hands and get started on the new material, the Nylon 11 carbon fiber?
Nylon 11 carbon fiber, that's actually a very commonly asked question. The one thing I do want to highlight with Nylon 11 carbon fiber though is that it's only available on the Fuse1 Plus 30 watt. So if you're currently using the Fuse1, you do have to get another Fuse1 Plus 30 watt to use Nylon 11 carbon fiber.
Okay.
So that's one way to get started.
Great. If you want to sort of try out with like Nylon 12 first, if you get a new machine, the Fuse1 Plus, and you wanted to then go on to the carbon fiber, Nylon 11 carbon fiber, how easy is it to do that?
Switching materials is a very common question, so thanks for asking that. So switching between materials for SLS is not as straightforward as other 3D printing technologies on the market. So it is a little bit of an extensive process, a lot of vacuuming, a lot of wiping. So essentially, if you are switching from, let's say, Nylon 12 to Nylon 11, which have different melting temperatures, it's really, really crucial that you wipe off every remaining powder that you have, both in the Fuse1, which is the printer, the Fuse sift, which is the post-processing, and of course the build chamber and the powder cartridge. So a lot of things to clean out. However, if you are switching, let's say, between Nylon 12 and Nylon 12 GF, which is the same base material, which has a very similar melting temperature, you don't have to go through so much of an extensive clean out process. So either way, you could probably get it done, let's say, in a day. If you are planning on, let's say, using multiple materials, it's better to have a material per printer and a Fuse sift per printer. So at Formlabs, I think we do have a lot of customers using multiple materials. But for example, let's say in a university, they say one semester is going to be this material and the next semester is going to be another material, let's say. For those scenarios, it's okay to have that one printer and have it switch out because you're not going to be cleaning so often. But if you're constantly, say, running different materials, I think it's a good idea not to do that cleaning out process a lot. One good thing that you did mention though is the hopper clean out. It's essentially dropping all the powder into the build chamber. It's actually one of our newest addition to the firmware update. So keep your software updated. So that's one key thing I do want to highlight.
Absolutely. And is there a change to the sift at all if you want to swap between, say, the carbon fiber? Because I heard something about the sift needs to be different.
Thanks for mentioning. So I don't think we covered a lot about the Fuse sift, but the Fuse sift is the post-processing station where you have to sift out or essentially excavate the 3D printed parts away from the reclaimable excess powder. So when you put those excess powder away, it actually goes through a sieve. The sieve is currently, I think it was around 150 microns, but the carbon fiber particles are larger than that. So you do have to change out the sieve. So the sift is the same, it's just one part that you do have to switch out if you're using Nylon 11 carbon fiber.
Dead easy then, brilliant.
I also do want to highlight a little bit, which is different. Nylon 11, Nylon 12, for those who are already using our 3D printer, it's a little bit different. If you go to Nylon 11 carbon fiber, you do have to take extra precautionary steps of covering up your skin because it is a sensitizer. So just a heads up on that.
Yes, you need a bit of extra PPE, not just your standard nitrile gloves.
Exactly, wear your masks as well.
Well, speaking of powder then, you've got this fantastic new material. I guess my question is, what's next as well?
Well, at Formlabs, I think SLA is a very good example. SLA is the other business that we have where we're making that polymerization 3D printers. We make 3 different materials every year and we're constantly expanding with 30 plus different materials. SLS, we are relatively new in the market, so currently you're right, we only have 4 materials, but there's always a lot more coming up. We're going to match whatever we do with SLA, so plenty more to look forward to.
Okay, excellent. Well, I'm very excited about that. with the printer, with the Fuse1 and the Fuse1 Plus 30 watts, we do offer various sort of packages that we can do. So standard printer packages include everything you need to get actually started with the print process. So the printer itself, the finishing station, some powder to get you started too, plus obviously the build chambers and the powder cartridges. We do also offer a bit of training and support in there as well. But in terms of sort of cost, we can actually expand the cost to cover over a year, 2 years, 3 years contracts. So you can pay in installments instead of just a one-off cost. That's definitely something that small to medium-sized businesses are very keen to explore and to know about. And then of course with the support side of things, I'm a technical support engineer, so we're always in the office to help guide you through any issues or any questions that you guys might be having with that. And we do offer a really great training program as well. So the training course usually takes about a day and a half, where for the first day we'll come on site, we'll show you everything there is to know about the printer. We'll basically expunge our knowledge into your brains, and we'll basically try to get you set up and started with your first print. Obviously we won't be able to excavate that print straight away, so then the half a day is usually a virtual session the next day where we'll be able to actually take the parts out virtually and show you through the sift process as well with our in-house machines too.
I think that's really important, especially for industrial grade machinery. So you take that extra time, and it's great with Solid Print 3D because you guys are really local. Do you guys also take into consideration like maintenance? Is that something you guys offer?
Yeah, absolutely. So we can get support contracts for a number of years, and that contract includes us going on site to sort of maintain the machine, clean it up after a year or so. And we do also offer preventative maintenance visits as well. So to avoid things going wrong in the future, we'll come on site beforehand and actually swap sort of components out and really help to keep your print process up and running with minimal downtime, really.
You guys do.
Yeah, and of course, speaking of sort of investments as well, the return of investment on these machines are just insane, aren't they?
I would like to think so, yeah. Especially it really does come down to how you use it, and I think that's why it's really important that you guys do the training. Having when you're packing a lot more, you're more likely to meet your ROI. So I really appreciate that you take the time to do all the training. On top of that, you guys do a lot of servicing, also training, but you also provide other services in post-processing as well, right?
So yeah, in terms of post-processing, obviously we've got the Fuse sift to start off with. That's kind of the basic principle, staple post-processing station that you always got to start off with, but there is also, I think, a compulsory post-processing station after that, which is just a general media blaster.
A media blaster is definitely recommended. You can't really brush off all the powder on the sift anyway, so we do highly recommend it. For certain materials, like let's say nylon 12 GFD, the shell around it is really, really hard. That media blasting is totally mandatory. You won't be able to do it off, brush it off with your hand. And it's honestly a very tedious process, so I think that's one of the reasons why you guys have other potential post-processing options, right?
Absolutely. So we offer a couple of post-processing stations here, and we can include that in the whole package as well. So there's AM Efficiency and AM Solutions as well. So these two machines, one of them is a big sort of tumble blaster, and it will actually vibrate and polish your parts off quite nicely. And the other one is an automated post-processing unit, which will basically, again, tumble your parts around, but it will spray it with beads. It will then actually dye the parts as well. So that dyeing procedure will colour them and then polish them off to make a really, really nice crisp finish. But with, I know especially with nylon 12, because we've been experimenting with it here, but there are a number of different things you can do to it as well. For instance, you can paint it and dye it afterwards.
Yeah, absolutely.
Is that the same with some of the other powders as well?
Absolutely, yeah. They're essentially normal plastics, so you can do whatever you do with normal plastics. And I really appreciate how you're looking into other post-processing stations, especially for customers in manufacturing and production. It really doesn't make any sense for them to be manually post-processing it by hand, so I think having that option is really great. There are other post-processing stations that add in a little bit of mechanical properties as well, and those are some of the options a lot of the users do look into if they're using it for final end production.
Because people think it's a powder, so it might absorb water. So we've actually had quite a few people ask about how well does it absorb the paint, how well does it actually work underwater as well, because I know there are some lacquers that you can get for it as well.
Yeah, absolutely. So SLS in general, not just in Formlabs, but SLS because it's a powder-based 3D printing, it is porous by nature, but it's the first few layers, so it's not It will still absorb water. So especially if I'm looking into customers, let's say in biocompatible applications where it's in skin contact, they would prefer the part to be completely non-porous, so it doesn't absorb any moisture essentially. So for that, a lot of users do look into, say, vapor smoothing. I think that's one of the options that is very common as well. And on top of that, painting, you're right, it does absorb a lot of paint. And on top of that, when you're gluing parts together, I've seen users use like a very thin glue. They do get absorbed and essentially won't stick together. You might want to think about using a thicker glue. So porosity is a factor that you do have to consider when you are post-processing with the Fuse1.
So there's a couple more things I just want to talk to you about as well with the new printer. First off, I think workflow. How does that differ at all?
The Fuse1 plus 30W and the Fuse1 has the exact same workflow. It also has the same post-processing station. So you start off with filling in the hopper, which is the orange part, and on top of that, you put in your empty build chamber, start print, and then that's pretty much it. So after that, you take out your print once it's done. You do have to cool it down. I do want to recommend for customers in production to have a extra build chamber so that you don't have to wait for the cool down inside the 3D printer. On top of that, I do also recommend that you don't do the cool down inside the 3D printer. It is an insulator essentially, so it will take longer for the parts to cool down. So you want to take it outside, cool it down outside. The Fuse Sift, which is the post-processing station, would essentially tell you what temperature it is and when it's safe for you to excavate the 3D printed parts. Once that's done, you go through the same process of removing the parts, brushing it down, potentially putting it in your post-processing stations. And then inside the Fuse Sift, there are two hoppers, which are essentially two storages. One has reclaimed powder, one has new powder. And essentially what I really like, and what I think makes Formlabs stand out, especially in the SLS market, is that refresh rates are done automatically. So to give you an idea, if I were to print a part that's 10 kilograms, let's say, and I'm running on Nylon 12, which has a refresh rate of 30%, essentially I need 7 kilograms of reclaimed powder and 3 kilograms of new powder. I'm not going to measure that on my own, it's all automatic. And that's
the scales.
I know, it happens sometimes. Other 3D printer manufacturers may not necessarily have that post-processing station, and I think that's where the beauty comes in. It's so easy to use, and I think that goes back to our motto of we create accessible, reliable 3D printers. On top of that, I've seen other 3D printers, let's say you put in 3 kilograms, you put in 7 kilograms. What do you do next? You have to mix it. The Formlabs Fuse Sift already has a mixer in place, so you don't have to think about, oh, I gotta shake this box of powder that's 10 kilograms. That's never gonna happen.
Go in with a whisk sort of thing.
It happens, to joke about it. There are people who have to do that. So the Fuse Sift is a really great addition. So the workflow is really enclosed in the ecosystem that we offer. But yeah, same for the Fuse1 plus 30W and the same for the Fuse1.
Excellent. And the new powder, obviously, the nylon carbon fibre, does that take the same amount of time to sort of cool down? But I know that the actual print process, though, is sped up quite considerably with the new printer, isn't it?
Yes, you're right. So so when you are printing, let's say you're printing a 10-hour print, the cool down time is actually a factor of the print time.
Okay, yes.
So obviously the longer the print, the longer the cool down time, the shorter the print, the shorter the cool down time. But there's not too much of a difference between Nylon 11 carbon fiber and, let's say, Nylon 11, Nylon 12. They're both above, well, Nylon 12 is around 180, let's say. Nylon 11 carbon fiber is slightly higher, but it's not to a degree where the print times or cool times will change.
Okay,
yeah.
But the actual speed of the print itself is
faster.
Faster, yeah.
For all materials, if you are using Fuse1 plus 30W, it is the laser that's three times more powerful. So the scanning speed has improved for all materials. So the print time improvement is reflected in all materials if you're using Fuse1 plus 30W compared to the Fuse1.
Okay.
Yeah. So refresh rate, essentially when you are printing with SLS, you can reclaim powder that hasn't been sintered. And then you also have to mix in new powder when you use that reclaimed powder, if that makes any sense. However, the reclaimed powder has gone through some sort of process where it's been heated up, cooled down. It's not the same quality as it was when it was brand new. So when you want to start a next print with the reclaimed powder, there's a percentage of new powder that you have to blend in to the reclaimed powder to maintain that mechanical property and, of course, a smooth surface finish. That's what refresh rate is. Essentially, the lower the refresh rate, the less new powder you have to introduce to your reclaimed powder, so it's a little bit more eco-friendly. The higher the refresh rate, essentially you have to introduce more new powder. So to give you an example, Nylon 12 has a suggested refresh rate of 30% to 50%, meaning if I were to run a 10 kilogram print, which is the example I gave you just now, 7 kilograms reclaimed, 3 kilograms new. However, if I were running the same print on Nylon 11, let's say, which has a recommended refresh rate of around 50%, if I'm doing a 10 kilogram print, 5 kilograms is reclaimed, 5 kilograms is new. So you could imagine opening a new bottle of new powder just to start the next print. Yeah. So having a very low refresh rate is always going to be better for you. And that's where we are quite competitive.
Is there a considerable quality difference in you know, if you have a 100% new powder compared to 50% new powder compared to 0% new powder?
Okay.
You know?
So the refresh rate is where we see the optimum, I would say.
Okay, yeah.
Yes. Obviously, new powder is going to be better, but 30%, let's say for Nylon 12, 30% is where we see a good amount that matches the mechanical properties. If you do say you choose to use 100% old powder, so that's 0% refresh rate, there will be some degradation in terms of mechanical properties. The part may be a little bit more brittle, and you may see some part defects on the surface, which makes it a little bit more coarse and rough. So that's what the refresh rate is.
So it's just best to stick to the recommendations.
I would say so, yes. And it's really easy to do it on the sift. There's a percentage, you can scroll it up and down. It's really what you want to do, but we do recommend 30% for Nylon 12, 50% for Nylon 11. Nylon 11 CF, 30% with nitrogen. Without nitrogen, it will be higher. Nylon 11 as well, if you are running it on the Fuse1 plus 30 watts, it'll be 50% refresh rate without nitrogen. With nitrogen, it will be 30%. So nitrogen does help out with the avoiding of degradation, so you can lower your refresh rate. So that's a really huge perk with introducing an inert gas atmosphere. But yeah, that's pretty much about refresh rate.
Excellent.
So, you've been at Solid Print 3D. Is there anything special that you want to talk about at Solid Print 3D?
Well, I've been working here at Solid Print for just over a year now, and I think it's been one of the best years of my life, to be fair. I think the atmosphere and the environment of the workforce here really does make a difference to both our behaviours and attitudes towards these machines, people's knowledge of these machines as well, and I think that's really reflected in our business and how we sell to people, how we support people as well. I think we've got one of the best training and support team in the UK, definitely. I think our sales guys really know their stuff. They can really help you out with return on investments, calculating all of that stuff, and what machine is best for you. You know, we don't just sell the products, we sell the solution. Yep. We did win the Partner of the Year awards for Formlabs as well, which is quite exciting. My boss happily received that when they went to Berlin a little while back, which was great. And I think from the sort of the business point of view as well, we are also a sister company with Solid Solutions, who sell SolidWorks. And that really makes a difference, because we're able to not only just help you with your machine, but help you with your process and your design as well. You know, we have the expertise and the knowledge to not just go and, you know, fix a fuse, or help you maintain it, or do whatever, train you up. We also can stay there and say, well, actually, have you thought about maybe designing it slightly differently? And we can take you through that and really offer a unique and personal experience for you guys. I know everyone that I've trained up, I know them all by their first names. I'm very friendly with them. I'm in contact with them still, and we have a good chat now and again. And I think that personal experience really does make a difference to everyone, basically, including ourselves, you know, including you guys as well.
Thanks. You really do have the full ecosystem, all the way from design to 3D printing and even post-processing.
We are the human embodiment of the Fuse1.
Great. So what's next?
Well, I think what's next is for you guys to get in touch with us. We'd really love to hear from you. I think if you do have any questions at all, or indeed if you've got any samples you want us to help you guys figure out and to print out, you know, you've got your own personalized stuff, we can help you with that. We can pop some of your designs on our machines, so you can really calculate what machine is best for you. You can calculate the ROI really easily. We'll guide you through all of that. And then if you want any more information, please do feel free to sort of book a private demonstration, and we'll be more than happy to oblige. You can phone us on 01926 333 777, or you can actually email info@solidprint3d.co.uk. Well, I think all that's left is to say thank you very much, Seiko. It's been really informative today. I've had a great fun filming this with you.
Thank you, Ben, for having me. I had a great time talking to you.
I think you know what to say now.
Yes, I do.
Don't just have a great day. Have a solid day. Happy printing.